Now, the last method, which is predictor corrector method, is the Adams bashforth method. In this method, a differential equation will be given along with the initial condition. So before we start and apply the formula for the predictor as well as the corrector, first of all, we compute y minus 1, y minus 2, y minus 3, and so on. Y minus 1, y minus 2, y minus 3, and y0 is already given. This y minus 1 will be equal to y x0 minus h. Y minus 2 will be x0 minus 2h. Y minus 3 will be equal to y x0 minus 3h. And these values can be computed, means y minus 1, y minus 2, and y minus 3 can be computed with the help of either by the Taylor series or by the Euler's method or by Runge-Kutta method. All these three methods can be applied to find out the value of y minus 1, y minus 2, y minus 3, and that can be computed as y x0 minus h and so on. Once we are able to calculate y minus 1, y minus 2, y minus 3, along with we know y0, we can calculate the value of f minus 1, that will be equal to f x0 minus h, y minus 1. F minus 2, that will be f x0 minus 2h, y minus 2. F minus 3, that is x0 minus 3h and y3. And y0, x0 is given, so we can also find out the value of fx0. So f0 can also be calculated with the help of putting x is equal to x0 and y is equal to y0. With these four values, that is x0, x0 minus h, x0 minus 2h, and x0 minus 3h, along with the value y minus 1, y minus 2, y minus 3, and y0, we then apply the Newton's backward difference formula. And this backward difference formula says that fxy is equal to f0 plus n delta f0 and n plus 1 upon 2 delta square f0 and so on. Now, the next value of y, that is y1, can be obtained with the help of y1 is equal to y0 from x0 to x0 plus h fxy. Now, putting the value of fxy with this Newton's backward difference formula on the right hand side, we will be having y1 is equal to y0 x0 plus x1. Instead of fxy, we put this right hand side value over here and converting this dx up into dh, and by that we know x is equal to x0 plus nh, so dx will be equal to h dn. So h will be taken common and f0 and delta f0 and so on into dn, and then we are integrating now. The x0 and x1 will also be changed. When x is equal to x0, n will be equal to 0. When x is equal to x1, x1 is equal to x0 plus h, so n will be equal to 1. So that is why it is from 0 to 1 and so on. And then whenever we are integrating, we will be getting y0 plus h, f0 plus 1 upon 2 delta f0 plus 5 upon 12 delta square by f0 plus 3 upon 8 delta cube f0. And neglecting the higher order differences, that is fourth order and above higher order differences. And then converting this delta f0 into f1 minus f0, delta square f0 is equal to delta f1 minus delta f0, and delta cube f0 is equal to delta square f1 minus delta square f0. And then calculating it, so we will be getting a formula that will be equal to y1 is equal to y0 plus h upon 24, 55 f0 minus 59 f minus 1, 37 f minus 2 minus 9 f minus 3. This equation, equation number 3, is known as Adam-Bashforth predictor formula. Now, this value of y1 can be computed because we know y0, we know h, we know 24, we know f0, which we have computed earlier. We also know f minus 1, which we have computed. We also know f minus 2, we also know f minus 3. Putting all these values on the right hand side, we are able to get the value of y1. But having found this value y1, we have to find out the value of f1. And f1 will be equal to x0 plus h, y1. Y1 is that value which we have just computed. Now, knowing the value of x1, y1 and f1, then for the better value of y1, we derive the corrector's formula by substituting the Newton's backward formula at f1. That will be equal to fxy will be equal to now this value has been put into the Newton's backward formula, so we'll be getting fxy is equal to f1 plus n delta f1 plus n into this, and then we are going to integrate with respect to x0 to x1, and so we will be getting like this. And after getting this this x0 and x1, so x is equal to x1 plus nh and dx will be equal to h dn. So once we'll put the value of x0 over here, so you will be getting -1 and x1. So first of all, Newton's backward difference formula is evaluated for the predictor method. We evaluate with y1 is equal to y0, and then corrector formula is evaluated with y1 is equal to y0. But instead of, now in that case, fxy is taken as f0 and delta f0. In the corrector case, we apply the formula that is fxy is equal to f1. Here it was predictor case, it was f0 and delta f0. Here I have taken f1 and delta f1, and then we have put this right hand side into the equation number 1 in this equation. So we will be getting y1 is equal to y0. Now f1, delta square f1, and so on. And now doing the same process, now here it will be, since we are taking f1, so x will be equal to x1 plus nh instead of x0 plus nh. So in this case, x0 will be equal to -1 whenever we are putting here x0, and x1 will be equal to 0. Now this value will be equal to 0. So in this way, whenever we are going to compute, higher order differences are ignored, and so we will be getting a corrector formula, that is y1 is equal to y0 plus h by 24 9f1 plus 19f0 minus 95f1 f minus 1 plus f minus 2. Now f0 is already known, computed earlier. F minus 1 is already computed earlier. F minus 2 is computed earlier, and this f1 is the value which we have found by computing the predictor value of y1, and through y1 we have computed the value of f1. So by knowing all these values on the right hand side, we can get the correct value or more approximate value which is near to the exact value as the value of y1. So predictor formula is y1 is equal to y0 h upon 24 f55 f0 f minus 1 f minus 2 and f minus 3. And corrector formula is h by 24 9f1 plus 19f0 minus 5f minus 1. And how this value we are coming, because we know delta f1 is equal to f1 minus f0, delta square f1 is equal to f1 delta f1 minus delta f0, and equating in terms of f0, f1, f minus 1 and f minus 2. So let us go with an example. Suppose the dy by dx is given as x square is equal to 1 plus y, dy by dx is x square into 1 plus y, and the initial condition is x0 is equal to 1 and y0 is equal to 1, as well as some value is also given. y1.1 is equal to given, y1.2, 1 y.3, and you have to evaluate the value at y1.4 by Adam bashforth method. It means the calculation of f0 can be done by putting here x0 and y0. You will be getting the value of f0. By putting the value of x1 as 1.1 and y1 as 1.2233, you can get the value of this. So how it has been done? The starting value is already given, so we have not to calculate the starting value. So what we do, considering h is equal to 0.1, we can obtain, we have already given that when x was 1.1, y, consider y as y minus 3, that is 1, and we can calculate the value of f minus 3 by putting here fx is equal to 1.0 and y minus 3 is equal to 1, so we are getting f minus 3 is equal to 2.550. Similarly, when x was 1.1, when it is given in the equation, and corresponding y is considered as y minus 2, so it is 1.233. It is given in the problem. 1.233. It is given in the problem. And f minus 2 you can calculate by putting a value of x as 1.1 and value of y as 1.233. So we will be getting 2.702. Similarly, at x is equal to 1 minus 2. Now this x is considered to be x minus 3. This x is considered to be x minus 2. This x is considered as x minus 1. And this x is considered as a x0. Correspondingly, we can find out the value of f0, f minus 1, f minus 2, and f minus 3. Once we know all these four values, we can use the predictor formula. We can apply predictor formula, that is y1 is equal to y0 plus h upon 24. 55 f0 minus 59 f minus 1. 37 f minus 2 minus f9 f minus 3. And putting all these values, considering x is equal to 1.4. So whatever value we will be getting at y1 of y1, that is the predictor value, that will be considered with value x is equal to 1.4. Means this will be x1 and this will be y1. And so corresponding to this x1 and this y1, which we have computed here by putting the value of f0 as 5.035, f minus 1 is equal to 3.669, considering f minus 2 as 2.702, and considering f minus 3 as 2.550. Putting all these values, considering h is equal to 0.1 upon 24, y0, we have already considered that it is 1.979. So we are able to compute the value of y1, that is 2.573. So x is equal to 1.4 and y1 is equal to 2.573. We can find out the value of f1 by putting the value in this equation, considering x is equal to 1.4 and considering y is equal to y1. So this is the predictor value which we have found as f1, that is 7.004. Now we apply the corrector method. Corrector method says that the formula is y1 is equal to y0 plus h upon 24, 9f1 plus 19f0 minus 5f minus 1 and plus f minus 2. So what will be the value which we will be getting? Y0 is equal to 1.797 because you see y0 is equal to 1.979. Y0 is 1.979, h is equal to 0.1 upon 24 into 9 into f1. F1 which you have just estimated, that is 7.004. Plus 19 into f0. What is the value of f0? F0 is equal to 5.035. So it is written 5.035. 19 into 5.035. Minus 5 into f minus 1. F minus 1 is 3.669. So minus f5 into 3.669. Plus f2, f minus 2. F minus 2 is 2.702. So plus 2.702. So we are getting 2.575. So the predictor value of f1, so predictor value of y1 is 2.573, and the corrector value of y1 is 2.575. Seems to be nearly equal. So this corrected value is considered to be the final value of the y 1.4.